Welcome to Dear SQL DBA, a podcast for SQL Server database administrators. I'm Kendra Little. This is episode 19 of the podcast, which it's hard to believe it's been 19 episodes. I learn a lot doing each one, and I'm really enjoying it. So keep the questions coming. Simple questions are great. Complex questions, I am happy to take a swing at as well. To submit a question, go to littlekendra.com and click on Dear SQL DBA at the top. It's really easy to submit a question. This week we're talking about index maintenance, specifically how to handle index maintenance for large indexes. Here's the question. Dear SQL DBA, do you have any advice for rebuilding indexes on very large tables? We've got a large table with over 2 billion rows. Index rebuilds consume over 300 gigabytes of transaction log space, even though we're backing up the log every 3 minutes. To solve this problem, should we reorganize instead of rebuild? Are there any issues if we never rebuild indexes and only reorganize them? We are using SQL Server 2014 Enterprise Edition. Well, I totally get this question. Been there before. Rebuilding big indexes causes big headaches, and it does seem like the faster that technology gets, the more SSDs we have, the more memory we have, the faster our processors are. Well, we just end up with more data anyway, so we're constantly struggling with maintaining these large indexes, and hardware never makes that problem go away entirely, although it can definitely help in some cases. Let's talk a little bit though about rebuilds and reorganize, and for each one, what are the pros and cons of them? Now, our questioner has Expensive Edition, aka Enterprise Edition in SQL Server, which is awesome. And that means that Alter Index Rebuild has even more perks that go along with it. If you have Enterprise Edition in SQL Server, you can use multiple processors to do your index rebuild, which can make it a lot faster. And you can also tell SQL Server to keep the table available for reads as well as writes while you do an index rebuild. So with Enterprise Edition, you can have lots of stuff happening in your database, although your performance may not be that awesome if it's a really big index you're rebuilding, depending on the storage and processor and memory resources it's using, right? But you do have that option to not take the table entirely out of use while you're doing the rebuild, which is huge. Online index rebuilds were added in SQL Server 2005, and I remember that was a feature that we were really, really excited about. You do have to know that at the end of the online rebuild, what it's doing when you rebuild the index is building a lovely, perfect new index structure. And then it's got to switch over to it at the end of the online index rebuild. When it's switching in at the end of that online period, it has to have an exclusive lock, and you can have blocking then. So it's mostly online. Recent versions of SQL Server have options where you can say, hey, I want you to wait at a lower priority and not cause such a massive blocking chain when you're switching in the index. And that's a really cool feature to make it less painful. Even that online option has a little bit of pain involved in it, which is really cool. Now, cons, if you have Standard Edition and you're doing a single threaded offline rebuild, which is what you get in Standard Edition, even rebuilding a non-clustered index, that entire table is offline while you're rebuilding it, not just the index that you're maintaining. So that's kind of a big downside if you don't have Enterprise Edition. Since it's doing this rebuild in a large operation, it defragments all levels of the index. So with large indexes, you might have a lot of intermediate pages in the index, and it puts those in order as well. So it's incredibly thorough, and it even updates the statistics. This little metadata description that describes, the density of the values in the index and sample values, it updates those because it read all of the data to do the rebuild, which is very cool. It can generate, as our questioner says, it can really whomp your transaction log. You know how I've been describing this as one large operation? Well, if we're in the full recovery model, and let's say I'm rebuilding a 100 gig index, I've got to log everything I'm doing. I've got to also allocate space in the transaction log in case it fails and I have to roll back, and I have to log my rollback. And I can't mark any of those parts of the log as available for reuse until the transaction is complete and I've done a log backup. And that's why it's using so much log, even though they're doing log backups every 3 minutes. Is the full recovery model, it's got to say, well, I have to wait not only till I'm done, but also till I've done the log backup, both. If you're using the simple recovery model, one perk of index rebuilds is that it can do minimal logging. And this is actually both simple and if you're using the bulk logged, which is a little less common. In those situations, for a lot of the index rebuild, SQL Server has the option to just log the extents where it's putting the changed data, or log less than otherwise. And if you're curious about exactly how much it would log, it does vary depending on whether it's an online rebuild or an offline rebuild. Kaylin Delaney wrote a fantastic blog post about how much will the index rebuild log in her Geek City series. And I'll have a link to that on the blog post that goes with that episode. So she even gives you sample code so you can, test this out on a database yourself and see the different recovery models and whether or not the rebuild is done online or offline, how much it logs. So very interesting, but you don't always get to just change your recovery model, right? So the simple recovery model is only appropriate if you can lose all the data between your full backups and you don't need point-in-time recovery. And a lot of systems, that's just not appropriate. We have to do index maintenance while in the full recovery model, either because we've got high availability, like availability groups or database mirroring, or because we do need point-in-time recovery. It's just a business requirement. It's a whole lot of databases. Having those availability groups or the mirrors makes life even more complicated for these large indexes because those technologies depend upon reading the stream of data written to your transaction log. So if you do a large index rebuild and you whomp your transaction log and you've got 1 or 2 availability group replicas and you don't have endless throughput to them, and maybe they don't have the fastest transaction log storage either, those replicas may get really, really behind. It may have a hard time catching up. It may be a really bad time. So having availability groups and mirrors and rebuilding these large indexes can be really, really painful as well because we can't just say, hey, use less log space. One option is to switch to Reorganize, as the questioner suggests, to more trickle information into the transaction log. Reorganize is still going to log a lot. It's not that it logs less, but it will log more slowly because it is slower. So this is kind of a pro and a con to Reorganize. Reorganize is always single-threaded. It works quite differently than Rebuild does. Reorganize just sort of trickles through the leaf level of the index and it defragments as it goes. It's just kind of like a Pac-Man, right? And if you kill your Pac-Man or cancel your Pac-Man, it just stops where it is. It doesn't go back and undo everything it's done so far. And that's a really big perk. So you could reorganize for a little while and then stop if your replica starts to get a little behind, or even if performance just starts to get a little dicey. that for these sensitive databases with very large indexes can be a huge perk. Another big perk is that it is always online. While the little Pac-Man is working the way through the index, you can read from it, you can write from it. It in every edition, it is online, which is really nice. It doesn't have that perk of updating the statistics, but again, it's not going to trigger plan recompilation either. It will apply any settings like fill factor, or if you're using the enterprise feature of like row compression or page compression, when you run a reorganize, it will reapply existing settings, but you can't change the fill factor or change the data compression. If you want to apply a new fill factor, a new data compression, you're going to have to run a rebuild command or a drop and create type command to set those. So when it comes to reorganize, it's kind of like, well, the good thing about it kind of stinks, right? So the good thing about it is that it can trickle stuff into the log, but like part of the reason that's good for these large indexes is that it's slow. Now, when it comes to standard edition, of course, just the fact that it's online all the time is a huge perk. So I don't want to make it sound like Reorganize isn't cool, because Reorganize is really cool, if only because it's online in standard edition, right? But we only get that one thread, and our little Pac-Man, he ain't so fast, right? And he will generate stuff that goes into the transaction log. It's just not wrapped in this big, giant atomic transaction that may have to roll back if it's canceled or failed. So what a lot of folks do if they start running into pain with these large indexes, and what I've done in the past is, when you start getting indexes that are so large that either they take longer than you have during maintenance, or they use so many resources that they impact performance and it's unacceptable, or they make a replica or a mirror fall so far behind that it's unacceptable. When you run into this pain, you exclude it from your traditional maintenance scripts, and then periodically during non-peak times, you manually run a reorganize command. Now, reorganize doesn't have the ability, you can't say alter index reorganized for 10 minutes. It doesn't have that parameter. So what you end up doing is having someone who's sitting with a management studio window open with reorganize running, and usually they're running you're running this like from something on the server itself, which isn't that awesome. You don't want a network connection between your client and the instance itself causing a big, causing confusion. Shouldn't cause a big rollback with reorganize. But they're running a reorganize command for a while, and they're watching query performance and other metrics to make sure that if things get slow, they can manually stop it. This is not awesome. This is not a great use of someone's time, and the experience is a lot like watching paint dry. So when you get into this situation, you typically start asking questions and inspecting it and trying to figure out, do I need faster transaction log to help this go faster? Do I need more bandwidth between my replicas to make this go faster? If so, can I get those? Or is there a change I need to make to break up the large indexes, which we'll talk about in a minute. So, this solution of reorganize is usually more of a Band-Aid than a long-term solution, depending on your budget and depending on your situation, because it isn't that satisfying when you really have 2 billion rows and your indexes are 70 gigs, 100 gigs, 150 gigs, and it's getting bigger. It's not going to get better unless you can change something. Sometimes you can change your recovery model if you do have periodic ability to have outages, right? Sometimes what you can do is, okay, we're going to let fragmentation get farther than we would normally for other indexes. I'm going to watch performance, make sure it's fine. And usually you can certainly let things get more than 5% fragmented without having performance go into the toilet. And you learn this when you have these large indexes. You're like, oh, we can let this get more fragmented than I realized without people noticing a performance change, because I don't see one in query runtime. But you don't want to let it go forever, because if you never maintain the indexes, they'll end up with tons of empty space in them if a lot of changes get made to the index. And then you've got wasted space in memory and wasted space on disk. And eventually you will have a performance issue if you never maintain an actively updated index. So you kind of learn to adjust your limits and thresholds based on your situation. Sometimes if you have the ability to have a periodic outage, like you've got a monthly maintenance window or whatnot, you can get your rebuilds in there. If you do change your recovery model to use that minimal logging feature and you're doing something like we're going to do offline index rebuilds in simple recovery model to make it fast, always know that, well, first of all, you can't do that with an availability group or a mirror. It just won't let you. But to get back into the full recovery model, research the backups that you need to take so you do have the continuous log chain and you aren't just breaking your log chain to be able to use that minimal logging feature. In other words, you do not want to have a job that just switches the recovery model for index maintenance purposes while people are using the system. You're going to break your log chain and you're going to have a period of time where you could have data loss that probably isn't acceptable because you're in full recovery model the rest of the time, right? So be really, really careful with stuff with recovery model. And then let's talk about this question. This is kind of the part of the question that I'm like, oh, this is sort of a toughie to answer. What if we never do rebuilds? What if we only do reorganizes? And like I said, if you've got standard edition, you may really want to reorganize whether or not your indexes are large just because it's online, depending on how much downtime you have in standard edition. Well, reorganizing is really, really good. And fragmentation in the intermediate levels of the index kind of sounds like a really big problem, like, oh, that sounds bad. Well, it's generally not. In fact, when I first started messing around with index rebuilds, when I was like a young DBA, I got really confused by the fact that I would rebuild an index and then I would check the fragmentation on it and I would see that it was still fragmented. Now, what was happening was I was doing the rebuild and then I was looking at the fragmentation, and I was looking at the fragmentation not in the leaf level of the index where most of the pages are, but in those intermediate pages, the ones that connect the root of the index to the leaf. And they were small indexes that I was rebuilding. So it would be like index, the intermediate level has like 8 pages and it has like 25% fragmentation. That's just how it is after you rebuild it. It doesn't always put them in perfect order, and it works just fine. Like, it's totally normal. So essentially, with really tiny indexes, rebuilding them doesn't matter. I typically don't even bother maintaining indexes unless they have more than 1,000 pages. And your leaf level of your index for most of your indexes is going to be the case. Yes, they might get empty space in them. Yes, they might be out of order, but how much of a difference is it going to make to query performance is the question there. Now, theoretically, it can make a measurable difference, and I'm sure in some really giant indexes, it does make a measurable difference. Maybe the measurement is in microseconds, maybe it's in milliseconds if it really gets out of hand. That's going to be a pretty extreme case, but sure, it could happen. Really, for me, what I would do if this was my case where I had a really large index that I couldn't regularly rebuild, I would use reorganize most of the time. When I had a maintenance window and I could fit it in and I could sneak in a rebuild, I would do it out of paranoia. But I would really attribute that to like my inner tinfoil hat wearing database administrator more than anything else, right? I wouldn't be satisfied with this, and I would want to ask, how can I make this better? I would really want to know if I've got this giant index that I cannot maintain normally, and I can't fix the issue with hardware, either more faster processors or more memory or more storage or more bandwidth. Do I have the option to break this index up using table partitioning? Table partitioning is a feature that is often misunderstood in SQL Server, I think. I did a video earlier this year called Why Table Partitioning Doesn't Speed Up Query Performance, because a lot of folks think that table partitioning is just going to make queries just automatically faster. It's not true. But it can be a fantastic tool for this problem, because what table partitioning does is, for these really big tables, it makes managing the data much easier because it breaks it into chunks. So instead of one giant index to rebuild, if we partition the table and we're able to break the table into reasonably even chunks, and this really depends on what the data is and whether it's suitable for partitioning, we can rebuild individual partitions, which now we have all those benefits of the online rebuild, but we're doing it in this small chunk so that it really shines and it's awesome, right? Table partitioning is fantastic for making large objects much more manageable when it comes to index maintenance, when it comes to backups, if you're using different file groups. Also, if you're using different file groups, it can help with CheckDB. It can be really, really great for this problem. So in terms of, I've said that, yes, Reorganize can be a helpful tool, but it's not really satisfying. One of the long-term solutions that can be really satisfying is using table partitioning to make it into digestible chunks. I should point out that one important change was made in SQL Server 2014, where we got the ability to rebuild individual partitions online. That is really, really cool. Prior to 2014, with a partitioned index, you could rebuild the whole thing online. But if you rebuilt individual partitions, that was offline. So we get online partition level rebuilds. And with the partition table, sometimes you only have certain partitions that get fragmented. But even if you need to maintain a bunch of partitions, you can work through them one by one, which is awesome. Breaks up the chunks going into the log. You can also, with index operations, you can say, hey, between each little bit of work I do, I want to wait a minute or whatever chunk of time is appropriate, so that you're not just like hammering your transaction log. You're more like hammering your transaction log, but like meditating between it. So you're giving time for your replicas to sync up a little bit before you dump more stuff into that transaction log. So these are my thoughts about indexes and rebuilding and reorganizing. With really large indexing, there's not necessarily a perfect solution that will fit everyone, because you can't partition every table. But you can ease the pain by using Reorganize when appropriate and checking if you do have the option to break that index up into smaller chunks long term. Thanks so much for joining me for Dear SQL DBA. Head to littlekendra.com to submit your own Dear SQL DBA question. Click on the Dear SQL DBA link in the header. I love simple questions. I love specific questions. I love all sorts of questions. So ask away, and I will see you again next week.